Thank you very much, Bob. That was very, very interesting. I'm sure we have lots of other questions. Before we take questions from the audience, I think we'll start with getting some from the panel. And I don't know, Lorenzo, do you want to start the discussions, or should it be arguments off, please?
I'm always a good one to start an argument, as you may know. So the question that often comes up when people, I have, we have our share of IPv6 skeptics at Google, and my favorite candidate is a man named John Doak, who doesn't like v6, and he likes v4, and he's slowly coming around. But the question that often comes up is, what were they thinking? Right? How can you design, and from today probably it just seems how can you design a protocol that needs to replace the internet and not design any sort of backwards compatibility to it? If you talk to Jeff Houston, he says, but my BGP with 32-bit addresses, with 32-bit AS numbers has backwards compatibility built in. What were they thinking? So what was it about the internet in 20 years ago that didn't make that seem like something that needed to be addressed at all? And I'm sure there were good reasons at the time, but from now, been looking at it from 20 years on, it's hard to know what it was like.
Just to pick a nit, it is backwards compatible. There's a version number field. If you want to continue to talk to IPv4, you use IPv4. What it's not is forward compatible. Okay, so devices that get v6 addresses and v6 addresses only are not reachable from v4 only. And that's because, so those guys only speak 32-bit addresses. And as soon as you have the guy who has the address that's 2 to the 32 plus 1, there's no way for the other guy to send a packet to him. So that's the forward compatibility problem. So, 32-bit IP addresses were embedded in every piece of code, everything that touched the internet. They get passed around as ints. They get put in packets and sent to other people and so on. It's like the Y2K problem. You basically have to go and find all those places and fix them. Now, you might have said if we had variable length addresses, this wouldn't be a problem, but I don't believe that. I think we would have ended up saying, okay, we have variable length addresses, but for now we're going to make the limit 8 bytes or something. And people would have wired that into their code and into their hardware implementations and so on. You still would have had to go out and touch every place. So people who complain about this problem, I don't think understand it or haven't, to me, described an alternative solution. The only one I could think of is we could redefine the 32-bit IP address, IPv4 address, to be a handle that actually identifies a bigger address. And so that all these old IPv4 systems could use this thing. They think it's an IP address, but there's some system out there somewhere that's mapping them into a bigger address. And so maybe the only addresses you would know about is your working set of peers that you're talking to. And so you could imagine doing that, but imagine what infrastructure you require to support that. You'd have to build something that creates these bigger addresses and the mappings and distributes them, because again, any host can take a 32-bit address, put it in a packet and send it somewhere else, anywhere in the internet, and it has to mean the same thing there. And so it would have to be a distributed database that maintains these mappings, that garbage collects them when people aren't using them anymore. And in the end, you still only have 4 billion possible active addresses at a time. And then that would be the next scaling limit we'd hit. So I've heard this criticism, but I don't, what's the alternative?
And the other thing is that even back when we did the early code, this was a heritage from the IPE side, was actually looking at how would we actually transition to something like this with people. I remember we had implementations of encapsulation as well as translation back in 1993, which is, this is the plan for how to go forward. Since then, there's a richer set of these things, but there was definitely a lot of thinking about how could you actually move to this thing, even though there are these fundamental limitations about fitting 33 bits into 32, etc. Right?
So one question I'm sitting here thinking, and perhaps I'm putting the cart before the horse, but we're thinking, what are the thoughts around the forward compatibility of V6, right? Because I made a comment to Lorenzo over here, and I said, are we going to be over there, in some number of years in the future?
So it's a good question. I mean, the way I think about it is that whatever causes us to go to another protocol later probably won't be address size. It'll probably be something else. Because I also start to worry that datagram protocol, you can't have an infinite size address in the header. The packets are, the header is too big. And so this doesn't scale up infinitely by just making the addresses, 10 times longer or something. So I think it'll be some other big technology change, something that we don't see today, that will cause us to change in the future. I don't think it'll be that we run out of addresses, assuming, of course, that the address space is managed prudently. We don't just give it all away this year.
Here.
I think the kind of the fear I have is that V6 is so similar to the same models of V4. I mean, if you look at a lot of the complaints, I worked with Tony Lee at Procket, and one of his big beefs with V6 was that it didn't change enough. And we lost some things like security, which I know that was really important. And then there was some...
Sorry, you lost?
We lost, like, we didn't gain security. We continue to lose the element of security.
We tried to make certain security parameters mandatory.
Right. So my I guess my concern is that, like, we didn't really solve the global routing table situation. We just allow it, if anything, we allow it to accelerate, right? That the prefixes is the same model. There were some proposals
that's based
like
on how you do aggregation. We had solutions to that too. But
there were like things like GSE, what happened to 8+8 and GSE, and then there was security built in, and then it seems like where we ended up now is just 128 bits, but we keep all the models the same. One could argue that, we keep all the models the same, everybody knows how to do operations. But why? How did we lose all the features that you guys originally wanted to have in the next generation?
Well, I mean, so these couple questions there's some similarity, with, Vint now sort of regretting he didn't make the addresses bigger and so forth. I mean, I sort of think about this as that back then, we were aware, the community was aware of all these other hard problems, but I think if we had tried to build for today's internet, it would have been too complicated and failed then because we didn't have the, processor speed we have today. Memory was much more expensive. V4 was actually very well designed for what it was doing around the time it was done, and it scaled really well. I mean, this is, regretting that it didn't, we did finally use up all the address space. This is a wonderful problem to have when you think about, other outcomes.
Another short question. I mean, is there anything you would do differently now if you look back at what you've designed? I mean, sort of with your hindsight.
yeah, I would have let Tubo win. No. In a sense, it had bigger addresses too, and yeah, there were technical arguments we had with that, but then some other people would have had to fight the battle.
But there were some things around, when we did neighbor discovery, one of the things we wanted to do, because we wanted to figure out how to assign addresses automatically. And at the time, there was this brand new protocol that some people were using for some flaky desktops called DHCP that no one really believed in, right? So that's sort of the historical context of this. So one of the things that we wanted was something that was a lot more robust. But the result of this is that we have two ways of assigning addresses. We have stateless address auto configuration, and we have IPV6. And this causes some amount of churn now because people, in essence, some industries or some companies or whatever, they tend to prefer one over the other, and then you sort of say, well, do these things actually all fit together? Because in essence, you have to do both of them everywhere for the stuff to work well.
I had a question that's more lines of deployment. What's your assessment of the 6-bone? And could it have helped with kind of the transition issues that we now encounter today? And could we have done something differently? Like I
Yeah.
6-bone was kind of before my time, so I don't really know the history of it and what it taught us and how the deployment was.
Well, I think it was very helpful for a period of time before, when there was, it's interesting, we're going through different phases, because we started out with more, hosts implementing V6 and very little in the middle. And so doing the 6-bone with, creating tunnels was actually a way of connecting all these little islands together. And I think it worked very well. We turned it off. It wasn't supposed to last forever, and it was turned off. But I think it was actually very helpful in doing a lot of early operational testing with the first set of implementations. I think now that we're seeing more backbones, we're seeing more mature host implementations, it's not necessary. But I think it was a very helpful step.
I have a different take on that. Yeah, so a lot of people were dissing tunnels yesterday. I'm actually a big fan of tunnels. I think the way the IPv4 internet was built originally was basically by tunneling over the phone system. Ignoring, getting leased lines, putting computers on the end, building a network with no cooperation at all from the phone company. And in fact, I once saw a phone company memo that referred to the internet as a hostile overlay. And we basically, demolished their billing plans and everything and built this network in spite of the desires of the carriers. And as I see the IPv4 internet getting more and more like the phone company, I thought one way to deploy IPv6 is basically tunnel over all that junk. Iterate the same thing again. And I gather that some people who are concerned about this are looking at other ways of sort of evolving the internet where you tunnel over HTTP or whatever you have to do to basically get over all that cruft and build a new network on top of it. And so that, to me, was one possible way we would, as the IPv4 internet rotted underneath, we would tunnel over it and then, throw away the rotted bits and replace them with wires.
Well, I think the only problem with that, Steve, is with the original analogy, it wasn't necessarily affecting the end user. It was an enabler. Things where people were able to leverage that approach to connect to things that they're interested in. Some of the stuff that we've seen, as part of the process of making V6 happen, is we're finding that some of those technologies present challenges that are actually impeding our ability in some cases to properly deploy V6.
Or that there's not enough motivation. Like, we tunneled over to phone company because we wanted V4.
Yeah, so,
there's killer apps for it.
Yeah.
If you joined it, you gained all this fantastic stuff. I don't know if we had the same
For
type
years,
of,
we sought the IPv6 killer app. That was obviously the silver bullet that would cause all of this problem not to be a problem, because people would want to go there and they do the effort because the only way you could run that app. So Facebook was only on IPv6. that would have done it.
And yet it turned out that the killer application for the internet is the network effect. And any small, even large improvement that you can put into a new protocol pales in comparison to the fact that you can do all this stuff on the internet today.
Yeah. So this whole process that Bob's showed started in 1991 or so. It's now 2011, so that's 20 years that this has been undergoing. But I remember at one point being frustrated by the slow pace of adoption back then, and Vint Cerf telling me, it took us 20 years to get IPv4 to the stage it was at when I was complaining about V6. And he said it's going to take another 20 years. And so here we are. All right.